Our special speakers for today, Marcus Cat. He's the co-founder and CEO of Microstream. He's the editor-in-chief for the Free Java Pro magazine in Germany and organizer of the Java conference, JCon. And he has 20 years of experience with his team on IDE tools for Java and database development. He's also the product owner of the Rapid Eclipse IDE project, which is an Eclipse Foundation project. He's also an international speaker at many development conferences, users groups, and jogs, etc. And then now, actually, I was supposed to introduce Christian, but Christian is not here today. And I'd just like to introduce Florian again and welcome again. You are the owner, right, of Microstream. So, and now the stage is all yours, Marcus and Florian. So thank you.
Hello, everybody. I'm really happy to be at Java User Group Chicago. It's really a pleasure. Unfortunately, only virtually, but hopefully next time on site. This would be fantastic. My name is Marcus, and yes, Mary already mentioned, I'm a CEO and co-founder of Microstream, and we are very proud and happy that we are now an open source project. And Microstream is the company behind the open source project. And today, this talk is about creating ultra-fast in-memory database apps and microservices with pure Java. Let's have a look on an agenda. I'd like to start with talking about some challenges with today's database programming in Java, and yeah, what we believe, what are the problems are and the challenges in terms of database programming and in terms of the performance of database apps built with Java. And then I like to talk a little bit about how we can fix that. We talk about the in-memory data processing approach that Microstream uses, and a little bit about our open source project, and then we will jump in the code, and Florian, our CTO, he will show yes, some code. And if you have questions, please interrupt me and ask your questions so we can do this in a interactive way. This would be perfect. And please leave your comments and also your opinion about Microstream and our approach. So this is very interesting for us, even if you're a database geek and so you're really convinced in database programming. That's perfect. So it's very interesting for us to hear. And I'm pretty sure we'll have enough time for Q&A. Yeah, Microstream at work. Mary mentioned it already. JCon conference is free to Chicago user group, so you can enroll for free. You can get a Java user group ticket for free on the JCon website, jcon.one. And it's also the workshops on the workshop day are free, and we have for instance, an Open Liberty workshop on the first day. So you can book all 4 days for free. You're invited. It's an online conference. We have about 3,000 participants online, and almost 30 Java user groups are supporting Java JCon conference. And we have another gift for you. On a Fastlane website, Fastlane is an education company. You can use our booking code and you can book a microservice framework training for free. And you can save up to $1,899. That's the normal price. And with our booking code here, and you can use this domain here, microservices.education. You can choose any course at any time, any time zone, and you can book all these courses for free. Let's get started. Software systems of of the future and even of software system of today, they produce tons of data, and they have to consume tons of data in the future, more and more. It's that everything is all about data and AI, machine learning, virtual reality. The question is, are our systems fast enough? And are our programming languages like Java, are they fast enough? And are the database systems of today really fast enough? And we dream about quantum computers to solve these performance issues, right? But perhaps it's possible to accelerate the software. And the developers, we see that they always fighting with performance issues, and the architecture gets more and more complex. And so this is the reason why we thought about that topic or that issue for almost 10 years. So this and we think that the systems of today, they are not really efficient enough as they could be, and this is the reason why we have to add in the cloud more and more machines. So this is great for the cloud vendors, of course, but our costs, they increase more and more as well. And yeah, the infrastructure costs explode, the infrastructure gets more and more complex. But when we have a look on Java, then we strongly believe Java is already fast enough. If we would use the core features of Java and the power and the speed of Java, then we could solve this problem with pure Java. And why? Because I think we have already the perfect data structure in Java. So for the performance, we have the JIT compiler, and the JIT compiler, accelerates a Java program up to speed like comparable to a C program. And we have already the perfect data structure. We have object graphs in memory, and we can build our object model freely with Java. We can use all Java types. We can also use build up complex structure, and also single lists. So we can use collections, everything that's everything that is provided by Java. And so this is already the perfect multi-model data structure. And the database vendors of today, they are working on multi-model data structure because they know that it's mandatory in the microservice architecture and in domain-driven design. So you have to use completely different data structure. And Java already provides that perfect data structure. And on top of that, we have already a perfect query language, and it's Streams API. And with Streams API, we are able to query object graphs, really complex object graphs in a memory. And even if you have perhaps a terabyte of data in memory, you can query object graphs in microseconds. And this is super fast in comparison to traditional database systems. What's the problem? The only thing missing, the only piece of puzzle missing so far was persistence. So the question is always how to persist my objects. And we have completely different strategies in Java, how we can persist our data, our objects. And one thing is very important, and I like to add this here, because the database systems, they work totally different from Java. In Java, we love object-oriented programming, type safety, and clean code, and building elegant object models, and POJOs is POJOs are very important. Yeah, clean code is always a topic on all Java conferences. This is very important for Java developers. But as soon as we want to store data, then we have to use completely different systems, and they work totally different to Java, and they perhaps they don't meet our requirements in Java, right? So the most common way is to use a relational database, and you guys know it's not possible to store complex object graphs in tables. So we have an impedance mismatch here, and we have several mismatches here. So this is not possible, but we use frameworks that solve the problem, and the standard is JPA to solve this problem. And even when we use NoSQL database systems, they are not using table anymore, but they use now different data structure, key value and graphs, object-oriented databases, you know, document-based, for instance, JSON. But all these data structure and all these formats are also incompatible to Java object graphs. And this is really interesting because all data structures of all database systems are incompatible to our Java object graphs. And this is the reason why we need a mapping between our Java layer and the persistence layer, between our application and our database. And what does this mean actually? Have you ever measured the time after or a query takes? Not only the SQL is processed by the database systems, but additionally the time. How long does it take to produce the objects again? And this is really time consuming. And for me, it was really shocking. How long does this take to generate the objects behind the scenes? And this is always a latency, and it's really expensive, requires lots of computing power. It reduces our performance, and this is, my opinion, the reason why the architecture gets more and more complex and the performance goes down. And this is the reason why we by database programming with JPA, mostly Hibernate, is that complicated. Yeah, and shocking. I mentioned the word. I used the word shocking because I grew up with Atari playing and assembler programming and basic programming, and I have learned if you want to have access to the memory, then it should take only nanoseconds, or if you have an algorithm, a bigger algorithm, more complex, then it should take microseconds. But if you have access to the memory, it should not take milliseconds. Something should go wrong here if it takes milliseconds. And when we read directly from a local cache, if you use, for instance, cache, and you read the data directly from the cache, so we measured that, and then we saw it takes milliseconds. Mostly it takes milliseconds. And this was shocking for me because I had expected it should only take microseconds. But the reason for that is, in Wikipedia, we have an article about this object relational mapping topic. And as long as the problem exists, and the problem is incompatible data structure. As long as we have this incompatible data structure, we will run in these problems. So your system will get more and more complex, or your performance will go down. So you can't fix the problem. And for the developers, we have the problem that we have to deal with two data models. So we have our Java classes in Java, and we have to create our data model in the database as well. So we have to do this twice. And yeah, we have to, we say we have to build our object model around the database because the data structure are incompatible. So we have to build our data model that is suited for the relational model or for a NoSQL model. This is effortful. And when we have a look on the concepts of the databases, then the database vendors, they tell us we have all these native functions, so use them. Use stored procedures, use stored functions, use PLSQL, and all these native functions of a database. But when we have a look on the JPA standard, then the JPA standard ignores these native functions of a database, actually, because our idea is, and what we want in Java is persisting, storing our objects, not using native functions of a database systems. We believe we can do this in a Java native way, in a Java way. We can do this better than in databases. So this is the reason why most Java programmers do not use stored procedures. So this is the reason why we were wondering, can we do this? Can we build a persistence layer that is really Java native? That feels like Java and feels like a real native function of the JDK. Would that be possible? This actually would be a Java developer's dream. And if we would be able to do that, then we were able to build ultra fast in-memory database apps. And yeah, of course we can do that, and we can do it already. We can do this almost 20 years ago, but we have, yeah, to think in a different way. So you have to change your mind. So you should not think like a database programmer and a database professional. Please think like a Java developer and think in an object-oriented way. Then it will be much easier to understand that approach. But the approach actually is really easy to understand. So we would say Java is the perfect high-performance in-memory data processing reactor. So it's super fast. We have super fast JVM, and now we need persistence. And an old Java developer stream is we have persistence already. We have the Java serialization. We can serialize our objects, and then with serialization we can persist our objects. And store them on disk and restore our objects in memory very easily. And this is the Java developer stream because the only thing you need is serialization. You need your Java classes, and that's it. But we have some problems here with this architecture. It seems really simple, and it's really simple, but also we have challenges here. We have not enough memory perhaps, and serialization is not fast enough. It's insecure, and we have other issues here. And we really have a kind of like pattern for that. It's called system prevalence, and it works like mirroring the state of your application to the disk. So simply using serialization and store your objects persistently on disk, and the state of the application is kept in memory. That's it. And even Martin Fowler has written a blog post about prevalence system, and he saw such a system on a conference, and he was very excited about that. And yeah, unfortunately, this article is from 2011, so it's old, and it seems that this concept is not much popular. Why? Because there are many challenges about system prevalence. The snapshot sizes can be too big, and snapshotting your anti-object graph, which means it's your anti-in-memory database, take too much time. You have a latency there, and between the snapshots you can lose data. For microservice architecture, this approach is not really working, because in microservices you need fast startup times, and if you have to restore your anti-object graph, which means your anti-memory database in the memory, then this will take too much time. Then you have perhaps problems with the RAM size, and of course garbage collector issues. If you have huge RAM sizes, and then additional problems. What happens if my classes change? And what happens if the storage grows more and more? And of course, we have issues with the Java serialization as well. So perhaps these are the reasons why system prevalence, that approach, does not really work in practice, or was not really popular so far. With Microstream, we do this totally different, and we have solved all these issues here. We solved them all, and now system prevalence with Microstream, this works perfect. And now I'd like to introduce you to Microstream, how this works. Microstream is not that young project. So we started in 2013, and as a so it was a project started between our additionally to our core project. In 2013 we have worked on 2 Java development environments. So here we were working on, we have improved the Hibernate, JBoss Hibernate tools, and in parallel we started with Microstream. And 2 years later we used Microstream at a big company, and this worked really so fantastic that we decided we have to build a product. But it took some years, and then in 2019 we founded the company, and 10 months later we launched Microstream as a freeware, as a free software. And we're located here in Germany, and we have German investors, and open sourcing software in Germany. This is so we use a lot of open source software in Germany, but building open source software and finance open source software by funding, this is difficult, because in Germany all the investors, they want to protect the invention and not to open source it. So it took 2 years, two more years to open source it, and now we are really proud and happy to be open source. You can find us on GitHub, and thanks to all Java user groups, by the way, because in the time where after we founded the company and we were closed source, we had the chance to introduce Microstream at numbers of Java user groups, and they gave us feedback, and they were keen on getting the code, and they wanted to have us open source. And now we can give value back to the community. So thank you for that. And now we are working on integration with Helidon and integration with OpenLiberty, and the integration with Helidon comes in 2 weeks, and we are working also on OpenLiberty, and we hope we can launch the integration at the JCon conference. So we are working on that. Yeah, you can find us on GitHub. And for us, now we do not earn money with selling licenses. So how can you feed us? Please star us on GitHub. This will help us. Thank you. Yeah, we're working on integrations and microservice frameworks, and here we work together with the great vendors and the teams working on this microservice frameworks. About Microstream, how does this work, and what actually is Microstream? The Microstream core is a serialization, and it's very important to mention here that Microstream is not the Java serialization. So it's our own serialization we have written from scratch, and it works fundamentally different to the Java serialization. For instance, not possible to inject code through deserialization. So Microstream serialization is really highly secure and up to 20 times faster than the Java serialization. Okay, my animation does not work here on the Mac. On top of our serialization, we have built a communication layer for transferring object graphs, and with this communication layer, you can transfer your objects, and you can synchronize object graphs between JVM nodes, and also it works on Android, so you can synchronize an object graph running on a JVM node and an object graph running on an Android node, on the Android device. But this is not our topic of today. It's persistence. And we built a persistence layer for the JVM and for Android. And then we solved all these problems with systems prevalence, which means what happens if my class is changed. So we built a kind of like a legacy type mapping. We called it legacy type mapping. So this is solved by the engine automatically behind the scenes. And what happens if my storage grows more and more? So here we have built a kind of like garbage collector that works on a file base. So it removes the legacy types from your storage and keeps your storage clean. Then we build a file system abstraction that you are able to run Microstream in a container and store your data everywhere. Then on top of that, we built a database connectors that enables you to persist your objects even in a database system, even in a relational database system or a NoSQL database system. Here we store the blobs. So this is not an object relational mapping behind the scenes. Be careful. We always serialize the data and store the blobs, and to enable you to use a database system for persisting your objects, you can use the database connectors. To enable you access to your storage data, we have a REST interface. And on top of our REST interface, we have a graphical user interface that enables you to browse through your storage data. And we have native backup functions. That's Microstream. And here we can see the architecture of a Microstream app. We have you can use it for building monolithic applications as well as for tiny microservices. And you only have your object graph in memory. That's your in-memory database. You won't need any caching framework. So your object graph is in memory. So it's in memory already. For querying your object graph, you can use Streams API or GraphQL, and then you only need Microstream, and Microstream is it's a tiny Java library download via Maven, included in your Java app and in your Java project. That's it. It runs within the JVM process of your app. And then you can decide, you can choose your persistence strategy. You can use plain files. You can use a database system. You can also use a NoSQL database. You can also use a distributed cache like Redis, or what is perhaps more interesting, you can also use Kafka. You can store your objects in Kafka and read from your objects from Kafka. And there is no more mapping behind the scenes. So mapping eliminated, any data conversion eliminated, simple architecture. So we save lots of CPU power and minimize latency. So actually this is a low latency system or a no latency system. Everything runs in memory with Java almost in real time. And in real world projects, our customers really save up to 90% cost of infrastructure because of this performance. You can see the data storages and Microstream runs everywhere. So in containers, on desktops, mobile devices with Android, and the only requirement really is Java version 8. That's it. You can also use any JVM language, and it also works with GraalVM native images. So this is pretty cool because actually serialization and GraalVM native images, this is a little bit tricky, but you can use Microstream serialization. It works perfect with GraalVM. Florian, perhaps you can show our performance demo before you jump in the code. We have proven that database queries with Microstream are up to 1,000 times faster. Sometimes only 10 times faster, mostly between 100 and 200 times faster, but sometimes really more than 1,000 times faster. What are your benefits? With performance, you now can build applications that are really super fast and build revolutionary new apps and features that were science fiction some years ago. You can save lots of infrastructure costs because this is really an application where we built with the insurance company Allianz in Munich, Germany, and they wanted to run a huge cluster. And this was a very important application that is used in 22 organizations worldwide. And today this application runs on only one single machine with Microstream. Actually, they have two machines because we have a failover architecture, but the traffic and the workload is handled by only one single machine because of the power of the JVM. And for you guys as Java developers, you have great benefits because it's so simple to build a database app with Microstream. It's even easier than using NoSQL approaches. So Doran will show code in some minutes. How does this work? Here we can see this is how your class will look like. So you see nothing but Java code here. So no annotations. We do not need a super class. There are no implements you have to implement. No interfaces you have to implement. So no annotations, really pure Java clean code, fantastic, beautiful Java code. That's it. POJOs. And if you want to store your object, then you only have to call one store method. It's an atomic operation. We serialize the object, or mostly in practice, you will store object references, subgraphs. Not only single objects. It would be a little bit too expensive, mostly subgraphs. And we serialize the subgraph and store the serialized data appended to the storage. So we have the appended log strategy. So if you call the store method 100 times, Microstream will store your object 100 times to the storage. This is not the problem because we have this garbage collector that removes the legacy objects from the storage and keeps the storage clean. And so this problem is also solved. It's strong consistency and consistence, and it's transaction safe. Yeah, here we can see how we stored the binary data appended to the storage. You also can use channels, which means the IO operations are executed multi-threaded to accelerate your performance. It depends on the hardware, how performant your application will be. And if you want to load objects, then you can use eager loading or lazy loading, which means you do not have to load your entire object graph in the memory. You can do that. You can load your entire object graph in memory, which means you would load your entire in-memory, your entire database in memory. Then you have your in-memory database. But you can also use only 4 GB memory, and you use lazy loading to load only some object references in the memory that you need immediately, and all the other object references you can load on demand when needed. So this is very important to mention. The prevalence system says actually the pattern you have to load the entire database in the memory. With Microstream, this is not mandatory. Yeah, here we have a slide that shows you can use, if you have enough memory, only have, perhaps you have 256 gigabyte memory, only 100 gigabyte storage size, load the entire database in memory. If you don't build a microservice, so it depends on the startup time. If this doesn't matter, load the entire database in memory, it's super fast. If you have only 32 gigabyte RAM, but you have a terabyte database size, then use lazy loading. Or if you build a microservice, then use lazy loading, load only the engine, that's it, and then your microservice will start super fast. Queries, super easy. This is core Java. You can use Streams API or GraphQL. And you do not have to manage your memory. It's done by the JVM, but you can manage your lazy references. So at any time you can, if you load references, object references lazy in the memory, then you can clear your object references anytime to save memory size. And if you have concerns about your memory size in terms of garbage collector issues, then yeah, you can try Azul JVM. And the Azul guys, they told us they can manage 20 terabyte of RAM size without garbage collector issues. Wow, this sounds great, and it's a great combination with Microstream. Okay, too much slides, so this was a slide-full presentation. Florian, you have the slide-less presentation. Now we can jump into the code. If you have any questions, you can interrupt us. Florian, have you prepared the performance demo? Can you show that?
Yeah, sure.
Screen? Okay, great.
I'll take it over from here. The performance demo is located at our website. And here you can see 2 applications running in parallel, one run with Microstream as a storage and one with JPA. And the JPA application is running with a hot cache, so it doesn't have to query the database all the time. It's performance-tuned second-level EH cache. And Microstream is running basically without any caching frameworks. You don't need a Microstream has an internal caching built in, and there you can see the differences of the query times. So, of course, if Microstream doesn't need to do a lot of lazy loading, you can get up a factor of 1,000 or even more. And even if Microstream needs to reload data and merge it into the live object graph, you see factors down to 100 or 10. So that's mostly the power of the JVM. But compare in combination with the Microstream storage engine, you can achieve really quick query times and write throughput as well. So this application is not a fake. It's online at GitHub as well, so you can check out the source and run it by yourself in containers or wherever, and you can try it out if you want to. GitHub is basically a good point to start if you want to check out Microstream. At our site, you have different repositories. Our main repository, of course, and a Bookstore Demo. It's a big example application with a lot of topics built in, full text search, indexing, GraphQL, and based on Spring Boot and a lot more. And in the main repository, of course, you see the source of Microstream with examples as well. So if you're more of a code reading guy to get familiar with the framework, use our examples or the Bookstore Demo. On the other way, you can use our online reference manual, of course. And like Marco said, it's just a tiny Java library. Use your software management system of your choice, Maven, Gradle, whatever, and you're good to go. And the small Hello World application just looks like that. You have to start on embedded storage, and with the root method you can connect your object graph with the storage, and from the root object on, all data will be persisted or will be able to be persisted. And that's about it. Just a few calls and your default configured storage manager is up and running. So, but of course, if you want to change the default configuration, use default storage targets, not the local file system, or you want to store it to AWS S3 or to Kafka or different solution, you can just change the default configuration. It's there are several ways: external with configuration files or by code. It's described in detail in the manual, of course. So that's basically a good way to start. Or if you want to see a full application up and running, you can take a look at our Bookstore Demo, and this is a Spring Boot application. You can run it with one click in Gitpod if you want, or just clone it and run it locally. There is a little user interface coming with it. It's built with Warden, which is a Java API, which puts out a web application. And this demo basically mimics a company which runs bookstores around the world. So you have a pretty familiar object model which comes with purchases, customers, shops, and so on. So nothing new. And GraphQL, for example, is used to access your data from outside. You can do it with REST, of course, or different frameworks. It's basically all you can do with Java from there. We can take a quick look at the object model. Marcus showed it. You only have to use POJOs. There is no annotation, no Java IO serializable, no special superclass, super type, and there is no bytecode manipulation magic at the runtime as well. So you can be assured that your objects are untouched at runtime. In contrary to JPA, for example, there you have proxy types and manipulated types, which can lead to different runtime behavior, but that's not the case in Microstream. So, if you have any questions, feel free to ask them. I can see the Meetup channel and the WebEx chat is gone on my screen.
This is Bala. I have a query. See, I understand this is at the JVM level cache, right? When you have multiple instances, assume that one updates the data, how does the other one, which is having a cache, to get invalidated and rebuild the cache?
The cache is on the local side, of course. And currently the Microstream storage is a single VM approach. So you have one storage connected with one virtual machine. For an automated horizontal distribution of data, we are currently working on a solution. But if you want to do it right now by yourself, you can use third-party frameworks, Kafka, of course, to distribute your data, and use Kafka as a cache as well. It's done we have done it in several projects. It's a little work to do to distribute your objects, but we are working on a solution right now that you can scale horizontally without having to worry about the concurrent access or the distribution of your object graph. Yeah. But right now, out of the box, it's a single VM approach.
A question about the supported platforms. I do remember you mentioned quite a lot of them, but I was just wondering, have you ever tried to run your Microstream on Raspberry Pi?
Yeah, we tried it. It runs on ARM devices and on Android as well. So these are the supported platforms. Basically, wherever Java runs, yeah. And we had done some tests with GraalVM native, a little work for the refactoring configuration. There's a little project on GitHub as well, which shows the GraalVM native handling, and there you can see how to configure Microstream application to get the GraalVM native image up and running, and that's another way where Microstream can integrate very well. Yeah.
Great. Since you're the GitHub, I was just poking around the code, and I come across the class that is called persistent data type holder. Probably open it so we can see it. Just interested in the way you did it, meaning that it's an interface, and inside it you define a class. You call it default. Any reason why to do it that way, and the benefits? I think usually what we do, and I'm not saying that's the only way to do it, but kind of classic, once you have an interface, you have a class that implements it, right? So I wouldn't mix any class definition inside the interface, but you did. So I was just curious about what was your reasoning to do that.
Yeah, we adopted the original design from the base. It's interface first, so everything is an interface if possible, and comes with a default implementation which is inside the interface's file. It's one way to do it. There are several different ways, but we wanted to be consistent throughout the code, so we adopted the original design of the engine. Yeah. And,
okay, quite interesting. Mm-hmm. Okay.
Yeah, the big benefit, of course, no matter if you put your default implementation in the same class or not, or the same file or not, everything is interchangeable. So if you want to, you have special cases where you want to tweak Microstream's behavior. For example, you want to decide which fields are not persisted, the transients field by default. So you have a different approach, maybe with a name prefix or annotation or whatever. You can exchange the default implementation with the custom one, and basically every single bit of the engine can be exchanged and customized. Yeah.
Okay, thanks.
Do you use on-heap memory or off-heap?
Both. Most of the time, or if we can use off-heap memory, we will, because it doesn't put a load on the garbage collector, and if you at the point where we have to instantiate objects, we have to use on-heap, of course, but most of the time, whenever it's possible, we use off-heap memory. Yeah.
So that's internal to the implementation, or the user has option to choose between off-heap or on?
Theoretically, you could interchange. You could exchange the implementation, but it's a huge amount of work. I wouldn't recommend it, to be honest. The default implementation uses off-heap where possible, and on-heap where necessary, and that's the most performant approach. We did extensive testing, of course, and it's always better performance-wise if you use off-heap, because the garbage collector won't touch it, and we can use a better low-level memory operations to tweak it even further and get it even faster. Yeah.
Okay, thanks. Yeah, I was just curious because I think you mentioned Azul and garbage collection, so I was wondering, like, is it fully on heap? Because off heap you can bypass the GC.
Yeah. Basically, what it means, you can use huge object graphs. If the raw data or the cache data is put off heap, it doesn't matter. You can use really huge object graphs, and the SL virtual machine will handle it just fine. They have a basically zero latency multi-threaded garbage collector going on, and this virtual machine can handle huge amounts of heap. So there, it's not a problem. Yeah.
I was just thinking about one project to use it, and I'm curious what you think about it. Since you support a lot of platforms, including even embedded, like Raspberry, etc. Nowadays, you know that robotics are a pretty big field, right? And we already passed that point that we accept them. So to me, it looks like, imagine you just have a little robot, right, that does certain things, and you have to probably fill it out with some commands that it understands. I'm not saying that's the way to go, but potentially, right? So in your case, you can provide me with loading what I want. You can provide me with the performance, which is crucial in robotics, right?
Yep.
And then the persistence. So have you ever thought about using your project inside the robots to do those things?
Yeah, we thought about a lot of stuff where to put it, but we never had a project in the embedded field yet. So, but we tried it, we tested it on different devices like the Raspberry Pi and some other ARM devices, and it's running fine. And
Okay.
I don't see any problems running it in robotics as well, of course. Yeah.
Yeah, looks like it could be quite interesting, because again, probably what you have to do first, you have to teach the robot to do some things, right? And that would be the set of commands that you can upload using your approach. which is exactly in memory and etc. So I found it quite interesting in that regard. All right, thanks.
Yeah, welcome.
Yeah, basically we have developed that to replace Hibernate in our Java development environment, which was kind of like Visual Basic for Java, and so this was our idea. But basically, the only thing we do is storing and loading object graphs. So this is really abstract. So you can do everything with Microstream. So there are so many different use cases. And in November, we will launch our Microstream Summit conference, and there we will show many different use cases. So we have invited speakers to build use cases that we have never thought about, that Microstream could be used for such use cases. So this could be very interesting. And if you're interested, this is, of course, free conference, virtual conference. So you can join that November 4th. We start in at I don't know exactly the time, but it's a time zone that is perfect for US people coming from US as well. So not only for Europe.
Yeah, I should get the link from you afterwards. Yeah, then I can announce it to our members too. So that's
sure.
Just a little addition. Since Microstream is basically everything in Microstream is based on a serialization engine we built from scratch. The storage engine as well, of course. You can use Microstream not only to store or persist data, but also to transfer data between different virtual machines or systems. And we had use cases, for example, to synchronize data from Android devices to the backend, or to synchronize machines in industrial staging. And there are many use cases we never even thought of course, or the community will try to implement Microstream or solutions with Microstream. So we are happy to adapt to different systems or to optimize for several use cases, of course. And that's one of the reasons why we are integrating now into microservice frameworks for Helidon and different other ones. We have right now in beta integration for Spring Boot to integrate better to a lot of popular frameworks and to get it to get Microstream adopted very or better or more easily in several ways. And we are happy to get ideas from outside, not just use cases, but technical ideas as well, of course.
For me, I'm just curious too. I mean, as such, is you're handling data on the object graph level, but how do we deal with like authentication, right? Authorization. Is there any security risk, right? On the fact that you're handling on that level, or how would you recommend? Yeah.
I recommend to use the authorization methods of the framework you are developing on, for example, Spring authentication or whatever framework you're building on. Microstream is just used for the storage, and the authorization is basically a different responsibility. Yeah.
See. Does anyone have any more questions for Marcus and Florian? Right now. I posted our Discord, the server room for more conversations afterwards too. I'm sure that some folks may think of questions afterwards. And then also today's session is being recorded, so we will be posting it on our YouTube channel when it is ready. So we'll do a bit of editing. Our volunteer would so. So, and oh, there was also a question earlier to Marcus. You pointed out there are some free courses that folks can kind of have credits, use some credits for. I forgot to actually jot down the link. If you have that available and post it for us, that would be very helpful. So thank you.
I put it in to Discord, and
Discord. Oh.
I put it in the chat as well.
Great. Awesome. Yeah, now I see it. Yeah. Cool. Thank you.
You're welcome. And we have a limit of 100 courses. So first come, first serve, but 100 courses should be enough for today.
Sure.
You can send it to your colleagues, friends, or partners, business partners as well. So if anybody's interested in a Quarkus course or Open Liberty together with GraalVM and hopefully additional Microstream, then you can book it for free by using our booking code.
Thank you.
Sure.
Does anyone have any more questions for Marcus and Florian at this time? I guess if not, since it's 20 minutes past the hour, so
okay.
There are no questions, I'll stop the recording, but if anybody wants to hang around longer, you're welcome to stay a bit longer too. So yeah, and
yes, I have some more slides.
That's right. Thank you so much, Marcus. Thank you so much, Florian. That's been very informative, very interesting to know about this framework. Yeah, so thank you.
It was our pleasure. Thank you for having us, and it was really great to be at Java User Group Chicago.
Thank you. Yeah. Awesome.
Thank you so much.
Okay.
Thank you.